So we're going to start off with basic trig, right? So we're going to be dealing with right triangle trigonometry. So when it comes to right triangle trig, a few things are still going to show up. So like, does everybody in here remember Pythagorean's theorem? Okay, so the generic Pythagorean theorem is a squared plus b squared equals c squared, even though Pythagoras himself never would have said it that way, right? It's leg 1 squared plus leg 2 squared equals hypotenuse squared. So why I make that separation is which piece is the hypotenuse? The longest side, and what is it across from? The 90. Okay, so when you're talking about legs, the A and the B, they have to touch the 90. The hypotenuse is the piece that does not touch the 90 on either side. Okay, everybody all right with that? The reason why I'm making that specification is sometimes we give you A and C, sometimes we give you A and B. It's important that you're plugging in for the right pieces, or else you will get the wrong answers at every step. Okay? So, SOHCAHTOA, right? So what does SOHCAHTOA stand for? Okay. So, let's go back. SOHCAHTOA. Okay, so SOHCAHTOA, right? So what's the S stand for in SO? Okay, so sine of our theta is going to be equal to, it is on the paper, opposite over hypotenuse. Everybody okay with that? And real quick, this is theta, which for us, we just use to represent an angle. Okay, so like, you know how X represents some random number? Theta represents any angle. Okay, everybody all right with that? Yes, no, maybe? All right, so what's the cos stand for? Cosine of theta is going to be equal to what? Adjacent over hypotenuse. Right, so CAH, cosine equals adjacent over hypotenuse, and then what's TOA? Tangent of theta is opposite over adjacent. All right, so you guys remember all this stuff from geometry, maybe? So back to the sheet that I gave you, right? What's important about trig is that the angle that they give you is the angle of perspective, okay? So for a triangle, opposite means that you're moving across the triangle, so you're moving through the triangle, right? Adjacent means you're touching it, right? Because adjacent means next to, so it's like we're touching it without having to move. So if I ask for sine of A, right? So sine is opposite over hypotenuse, right? So from angle A, here's my A, right? Which side is opposite angle A? Right, and what's the name for it? Little a, right? So we use lowercase for sides, and we use capitals for angles. You have to keep that straight. Okay? Angles are the big letters, sides are the little letters. All right, so if I'm asking about big A or big B or big C, make sure that you understand that that means an angle versus little a, little b, little c. Those are sides. Okay? So if that's the opposite, and then it's over the hypotenuse, right? So which piece is the hypotenuse here? Side C. So sine of big A is going to be equal to little a over little c. Everybody okay with that? So sine of big B, so again, now we're looking from B. Which side is opposite big B? Little b. And then what side is the hypotenuse? Little c. Okay? So these names are not arbitrary. We name the angles first, A, B, C, and then the side opposite the angle shares the name with the angle. It's just a lowercase version of it, okay? So side A is opposite of angle A. Side B is opposite of angle B. Everybody okay with that, yeah? All right, so moving on. Cosine is what over what? Adjacent leg, right, which means that it's got to touch the 90 over the hypotenuse. So cosine of A. So here's big A. Which side is, or which leg is touching angle A? Little b, right? Everybody okay with that? Yes, no? This side can't count because it's the hypotenuse. Okay? So that's what they mean by leg. Legs touch the 90. So we're going to be little b over little c because we still have our hypotenuse as the denominator. Everybody okay with that? Yes, no, maybe? I don't know. All right, so what's cosine of big B? So which side is adjacent to big B? Adjacent. Which side is touching big B? Little a, right? And what's the hypotenuse? C, so it's going to be little a over little c. All right, this time tangent, opposite over adjacent, right? So from big A, which leg is opposite angle A? Little a, right? So that's on top. And then which leg is adjacent to big A? So which leg is touching it? Little b. C is the hypotenuse. It's not a leg. Okay, remember, legs have to touch the 90. So it'll be little b. Little a over little b. Everybody okay with that? Yes or no? And then same thing from angle B. Which leg is opposite big B? Little b. And which side is adjacent to big B? Little a. So you're going to get little b over little a. So everybody okay with your basic SOHCAHTOA, you think? Yes, no, maybe? All right, so now we're going to actually start using it. So this is what you're going to actually be dealing with. So if I give you this, and the question asks, what are the 6 basic trig functions for theta? So what that really means is they want you to find the sine of theta, cosine of theta, tangent of theta. Everybody okay with those 3, right? Theta is like x. It just stands for an unknown angle because it's an object. So sine, cosine, and tangent are functions. So remember when we dealt with function notation last year, right, where it was f of x outside, and you guys were doing fog and golf and all that? We would go from f of g of x in parentheses, right? And then we'd start plugging in. Sine, cosine, and tangent are functions just like f was a function and g is a function. So it's not just some thing. It's an operation that we're going to perform on the numbers. But because it's in function notation, we have to put the function outside and then what we're taking the function of inside. So it'd be just like when I write out, if I gave you f of x equals 3x plus 2, and then I asked you to find f of 3. I have f, which stands for function, right, of 3. Well, the f and the sign are the same thing. They're both functions. The piece in the parentheses tells us what value we're using to evaluate the function for. Okay, so here I'm going 3, I'm substituting x for 3, and going from there. Here, I can work to get the answer out from theta, but I can also use the answer to work backwards and find what theta would make this statement true. So we're going to be working in both directions. One where I'm asking you to find the sine of theta, and then one where I'm giving you the sign and I want you to find the theta that makes it happen. So sine, cosine, tangent aren't just objects. They're actual functions like square root, but that's why we want to put them in parentheses, because we have to separate the function from the value. All right, so everybody okay with sine, cosine, tangent, right? Does anybody remember what are called the reciprocal functions? The reciprocal of sine is cosecant. Whoops, it'd help if I spelled it right. Is cosecant. And the reciprocal, so this is equal to 1 over sine of theta, right? Or hypotenuse over opposite. So that actually flips the function over the fraction. Okay, so sine goes to cosecant. The easy way to remember this, and this is going to sound a little weird for right now, is co becomes a no co becomes a co. So does sine have a co in it? No, so when I write it, what does it have to have? Its opposite has to have a co. So sine becomes cosecant. Everybody all right with that, right? No co becomes a co. Cosine, is there a co in it? So its reciprocal is going to have no co. So this becomes just secant. Secant of theta. Okay, so it's sine, cosine, tangent, cosecant, secant, and then cotangent. So no co becomes a co. So when I'm talking about the 6 basic trig functions, this is what I'm talking about. Sine, cosine, tangent, cosecant, secant, cotangent. Everybody kind of okay, you think, maybe? All right, now, since how we have most experience with sine, cosine, tangent, that's where we're going to start. And then I'll show you what to do with cosecant, secant, cotangent. Okay, I just want you to get them listed. So, sine of theta. So what's the angle that I'm looking from? I'm looking from theta, right? And what's sine equal to again? Use your SOHCAHTOA. What's sine stand for? What over what? Opposite over hypotenuse. Okay, so this is a 90. So this SOHCAHTOA only works with right triangles. So I have a right triangle. Which side is opposite to theta? 15. Which of the sides up here is the hypotenuse? 17. Okay, so what's sine of theta going to be equal to? 15 over 17. Everybody okay with that? Okay, now cosecant, secant, and cotangent are called the reciprocal functions because they're just the reciprocal of sine, cosine, and tangent, respectively. So what's the reciprocal of sine? So what's the reciprocal of 15 over 17? 17 over 15. Everybody okay? So now I know sine and I instantly know my cosecant. Any questions on that? Okay, how do I find cosine? Adjacent over hypotenuse. Which angle, or which side is adjacent to the angle of theta? X. Do I know X? Is there any way I can find X? Yeah, using what? Right, the Pythagorean theorem, because we have a right triangle. So, which side is my A? Does it really matter? Kind of. It can't be the hypotenuse, right? It's got to be one of the legs. So it can be X or it can be 15, but the A and B have to touch the 90. I don't care what order you go in, but A and B are legs, which means that they have to be touching that 90 degree. So what's 15 squared? 225, right? What's 17 squared? I don't know that off the top of my head. I think it's like 249 or something, or 256. 289? Okay, how do I get X by itself now? Okay, so what's 289 minus 225? 64, right? Okay, what's the square root of 64? 8. Now, remember, whenever we square root, we get a plus or minus, right? But this is a distance. So can we have a negative 8 as a distance? No, it's just like physics, right? If you're measuring a distance, it has to be a positive. There's no such thing as a negative distance, because even if you move in a negative direction, there's still distance traveled. Everybody okay with that? So we're only going to use the positive piece. So this is just X equal to 8. So my cosine, you said, is adjacent over hypotenuse. X is equal to 8. So what's the adjacent side to theta? 8. And what's the hypotenuse? 17, right? Can 8 over 17 get any smaller? Nope. So how do I find secant? What do I do with cosine? Just flip it. So what do I get? 17 over 8. Everybody good? All right, so last one, tangent. Tangent is what over what? Opposite over adjacent. So which side is opposite to theta? And which side is adjacent? 15 over 8. Can that reduce? Okay, so we leave it as 15 over 8. So what's the reciprocal of 15 over 8? 8 over 15. And that's it. Those are your 6 basic trig functions for theta. Okay, so there's a couple of things that I have to cover to make sure that we don't have mistakes. One of them is a format thing, and then I just want to get a little bit more practice in on this. Okay, one of the issues is when you're solving Pythagorean theorem, do we always get perfect squares like this out of Pythagorean theorem? No, only if it's a Pythagorean triple, right? So if you get something like, let's say you get X equals square root of 13, right? And you're working through, for cosine, it's not that big of a deal because the adjacent side is on top, right? So can we have a square root in the numerator? Yeah, can we have a square root in the denominator? No. So let's say we're working and we find out that cosecant of theta is 4 over square root of 13. Can I leave that as an answer? No. Does anybody in here remember how to rationalize a denominator? Okay. Kind of. We're going to multiply by 1 because we can multiply by 1 all we want, right? We're just going to be sneaky. Is the 13 okay to have in a denominator? Yeah, what's the only problem down here? The radical, right? So what's the square root times the square root? Like, what's the square root of 13 times the square root of 13? Just 13, right? So what we're going to do is we're just going to be sneaky in how we write 1. So we're going to get 4 square roots of 13 on top, all over square root of 13 times square root of 13 is square root of 13 squared, which just gives us the 13. Okay, so can 4 over 13 reduce? No, so this is what I need to see as an answer. Okay, you have to have a rational denominator in order to say it's a solution. Okay? So you are not allowed to have square roots running around in the denominator. You can have them on top, but not on bottom. Everybody okay with that? Yes, no? So where you're really going to run into that more than anywhere is when you're finding cosecant and secant, because those are the reciprocal of sine and cosine. Okay? So when you're using Pythagorean theorem, we tend to use it to find a's and b's. We don't. We usually give you the hypotenuse. All right, so everybody okay with that? Yeah? Do we know all three of our sides? So what do you think we should use? The Pythagorean theorem, right? So remember, we use the Pythagorean theorem when we know two of the three sides in a right triangle, right? So the 5 and the 12, are those a's and b's or are those c's? A's and b's, how do you know they touch the 90, right? So 5 squared plus 12 squared equals x squared. So you get 25 plus 144 equals x squared, which is 169, equals x squared, so x equals 13, right? Yep, 13. So let me get set up for my 6 basic trig functions. Opposite over hypotenuse, and which angle am I looking from? From the theta, right? So remember, whatever angle is here, if it's A, B, or C, or theta, this is the angle that gives you your point of view. So we're looking from this angle, which side is opposite my theta right here? You have to move across the triangle to hit opposite, so what side is opposite theta? 12. So that goes on top. And then which side is the hypotenuse or across from the 90? The x, which was 13. Is everybody okay with how I'm making this up? All right, so you got to make sure that you're using your angle as a reference point. Okay, that's where you're looking from. So imagine you're standing here, opposite is across, adjacent is your touch. Okay? And then 12 over 13, can that get any smaller? Nope. So what's the cosecant? 13 over 12. All right, cosine, adjacent over hypotenuse, so what's the adjacent side? And what's the hypotenuse? Can it get any smaller? Reciprocal? Yay. Everybody good? Tangent is what over what? 12 over 5. Can that get any smaller? Reciprocal? And there's all 6 of the trig functions. The next one we're going to look at is difference. So this style is the basic style. Everybody good with? Yeah? Now we're going to do something a little bit irregular. Yeah, if you have calculators with you, get them out. If you don't have one, I only have 4. So for this one, I actually give you the angle measure, right? If I asked you to find x and y, any ideas on how to do that? Okay. So well, no, that's fine. If you guys already know all the answers, then you shouldn't be in my class. So it's okay to not know. What's important is that we figure out how, so you do know tomorrow. If the angles inside a triangle add up to 180, and this is a 90, so it's 90 minus 30, so 60. So yeah, if I asked you to do it that way and find, the directions are going to be a little weird. If I ask you to solve the triangle, okay, that means find all 3 angles and all 3 sides. So if I asked you to solve the triangle, yeah, you would have to find angle A, and that would be 60 degrees. So I gave you the 30 degree, right? I'm asking you to find x and y. So from the 30, so first of all, sorry, which piece do you want to find first, x or y? So what's the relationship between the angle I gave you and the x? Is the x the side opposite, the side adjacent, or the hypotenuse? Adjacent. Okay, which other piece did I give you the value of? The hypotenuse. So which of our trig functions relates adjacent and hypotenuse? Is that sine, cosine, or tangent? Cosine. So that means that the cosine of 30 degrees has to be equal to adjacent over hypotenuse, which is x over 8. Everybody okay with that? Okay, so now how would I solve for x? What would you do to get x by itself? Multiply by 8. So you get 8 times the cosine of 30 degrees equals x, because these cancel. Now, when you're using your calculator, you have to make sure you're in the right mode. We have 2 different modes for angles, so it depends on what we're measuring in. I am measured in in degrees. So when you hit mode, you need to make sure you're in degree mode. So hit mode, if you're using a TI-30, or TI-80 rather. It's right next to the second. Hit mode, and you should see degree and radian. Make sure degree is highlighted. If you're using a TI-30 or just a scientific, when you look at your screen, you should see a DEG highlight. If you don't, there's a button up near the top that says DEG, RAD, GRAD, right? Degrees, radians, and gradients. So, yeah, GRAD, okay? You want degrees, so hit second and that button until you get the DEG up. Everybody all right? So now you just type this in. So you'll type in 8 cosine 30. If you're using a scientific that doesn't allow to do order of operations where you have to do it for the calculator, you'll put in the 30 and then cosine and then multiply by 8. Okay, so what do you get when you put in 8 cosine 30? Are you in the, I think you're in the wrong mode. 6.9282, and then what's past the 2? So that means that x is 6.9282 units long.